Hey, this is Joe, and today let's talk about polynomial long division. And the nice thing is, polynomial long division behaves fairly similar to the long division you already know whenever you're dividing two numbers. And if you recall, the structure for long division is shown here, where you have a dividend, a divisor, a quotient, and a remainder. And below, let's just match that up to what this means whenever we write it out in one line. In other words, the dividend and the divisor are the two terms that we're dividing. In other words, the dividend is the numerator of the division, and the divisor is the denominator. And that's going to be equal to the quotient plus the remainder divided by the divisor. And the main thing is, you do need to remember the structure in order to complete the process and then turn it into something that we can work with. So let's just jump right into a problem. Say we're told to divide the polynomial x to the third power minus 3x squared minus 6x plus 8 by x minus 1. Here, x to the third minus 3x squared minus 6x plus 8 is our dividend, and our divisor will be x minus 1. And so we can set it up in that format. Next, we're going to take the highest power of our divisor and the highest power of our dividend and say, what do I have to multiply our divisor value by to get the highest power or dividend? In other words, x times what will get me x to the third power? Well, that's going to be x squared. And so up top, I'm going to put x squared. And usually I align these quotient values with the similar term in the dividend. So I'll put this x squared above negative 3x squared. Next, we're going to take that value we got in our quotient and we're going to multiply it by our divisor and line it up underneath our dividend. In other words, we're going to take x squared, we're going to multiply it by x, and we're going to get x to the third power, and we'll put that below x to the third power within our dividend. Then I'm going to take x squared and also multiply it by the negative 1. And I'm going to get negative x squared, and I'm going to put that below negative 3x squared. If you remember, when you're doing long division, we always end up subtracting these terms that we put down here. And so sometimes it can be kind of hard to remember the values or the signs that I should have in front of these terms that I bring down here. And so usually what I do, instead of putting the minus way out front, is I just change the signs of these terms before I then add vertically. So I'll change positive x to the third to negative x to the third, and I'm going to take negative x squared and make it positive x squared. And this is probably the most common step that someone could make a mistake or forget whenever they're working with long division. Alright, now that we've changed the signs of these values, we'll just add vertically. So x to the third minus x to the third value is going to be 0x to the third, or just 0. And then negative 3x squared plus x squared is going to be negative 2x squared. Now, what we do is we end up bringing the next term within our dividend down to this same line here. And we're going to repeat the process we did before with x to the third power in the dividend, but we're going to now do it down here with negative 2x squared. That is, we're going to take the x that's in our divisor and say x times what will get me negative 2x squared. And that would be negative 2x. So I put negative 2x in our quotient, and we're going to put that above negative 6x. Now we take this negative 2 that we got, and we now multiply it by our divisor. So negative 2x times x is negative 2x squared. Negative 2x times negative 1 is going to be positive 2x. Now that we've put these terms down here, we got to remember to then change the signs. So this will become positive 2x squared minus 2x. We then add vertically, negative 2x squared plus 2x squared is going to be 0. Negative 6x minus 2x is going to be negative 8x. We then bring the next term from our dividend down to this level, and we repeat the process again. X times what gets me negative 8x? That would be negative 8, so that goes up in our quotient above the other 8. I then multiply this negative 8 by our divisor, so it'll be negative 8 times x, which will be negative 8x. Negative 8 times negative 1, which will be positive 8. Then I change the signs. I make it positive 8x, negative 8, and then I add vertically. And when you see I add vertically here, I end up getting a 0 down here. And that is something that we're generally looking for. That means our remainder is 0. Now that we've completed the division, how can we rewrite this? We've looked at one other method earlier, or one other form, where we have the dividend over the divisor equals the quotient plus the remainder over the divisor. Or we could also, an equivalent form, is the dividend is equal to the quotient times the divisor plus the remainder. So why don't we do that final form? And that will end up being x to the third power minus 3x squared minus 6x plus 8, because that's our dividend, is going to be equal to the quotient. Our quotient is the top here. That's going to be x squared minus 2x minus 8 times the divisor, which will be x minus 1. And notice, since the remainder is 0, I'm not going to add anything on the end here. Now I have this polynomial of degree 3 written as the product of a polynomial of degree 1 times a polynomial of degree 2, where degree, once again, is just the highest power of our polynomial. In other words, I factored my polynomial of degree 3, and I factored x minus 1 out. In other words, the whole point of this long division process is to generally get to this form where we're able to rewrite the polynomial of larger degree as a product of polynomials in smaller degrees. Okay, why don't we work with another problem? Let's try to divide x to the third power plus x minus 2 by x plus 1. Notice that I have no x to the second power in this top polynomial. When we go to write the long division out, we want to make sure that anytime we have a missing power of x, we put a placeholder 0 x raised to that power in its position so that we can do this algorithm correctly. So notice I'm going to put this 0x squared here as a filler whenever I put this in my dividend position. So we begin just like we did the last problem. The highest degree of my divisor is x. The highest degree of my dividend is x to the third power. So I take x times what gets me x to the third power? Well, that's going to be x squared. X squared times x gets me x to the third. So I put x squared up top. And I make sure I align that with my 0x squared. I then take the x squared I got up top and multiply it by my divisor. So I get x squared times x, which will be x to the third power. X squared times 1, which will be positive x squared. I flip the signs, and then I add vertically. So I get 0 minus x squared down here. Now I repeat that process again. I bring down my next highest power in my polynomial, or my dividend. I'll bring down x, and I repeat the process. X times what gets me negative x squared? Well, that will be negative x. So I put negative x up top above the x position. I then take that value, I multiply it by my divisor. So negative x times x is negative x squared. Negative x times 1 is going to be negative x. I flip the signs, and then I add vertically. All right, I get 0. I got, looks like 2x. We now bring down the next value, and we repeat the process. X times what gets me 2x? Well, that will be positive 2. I take the positive 2, I multiply it by x, that gets me positive 2x. Positive 2 times 1, that gets me positive 2. I then flip the signs, and I add vertically. So 2x minus 2x is 0. Negative 2 minus 2 is negative 4. Now, are we able to continue this process? Well, the answer is no. When I look down here at my next line, which is negative 4, there is nothing I can multiply x by to get negative 4, right? And I know I'm done with this process when the power of x that's down at the bottom here is smaller than the highest power of my divisor. So since I just have a constant down here, and my divisor has a value of x within it, then I know I'm done. So what happens when we write this one out? Well, it looks like we end up getting the dividend equals what? The quotient times the divisor plus the remainder. So I get x to the third plus x minus 2 equals x squared minus x plus 2, which is the quotient, times x plus 1, which is the divisor, all of that minus 4. That's the remainder. If you look on the right side, this is no longer a product of two polynomials. It's a product of two polynomials, but it also has a constant on the outside. And so in this situation, I do not have a factored form of my original polynomial, of my dividend. And so for this example, you would say that x plus 1 is not a factor of x to the third plus x minus 2. So that kind of brings me to, well, what is the goal of this process? Well, the goal of this process is that we want to find divisors, or divisor polynomials, so that the remainder is 0. This will allow us to rewrite that dividend polynomial as the product of two polynomials that have smaller degrees. And then what we would do is, within those polynomials of less degree, we would continue the process until we could factor it completely. I'm Joe, and thanks for spending some time with me.